The goal of today's lesson is to be able to graph functions in a much more efficient manner as compared to just graphing with a table. So what we want to do is we want to take a look at some rules or some shortcuts here that are based off of transformations or shifting our graphs dependent on a parent or based off of a parent function. So our parent function that we're going to take a look at in this lesson is the function f of x equals x squared, or a quadratic function. And so from that, or based on that, we have a number of different changes or adjustments that can take place. We can subtract a value within the parentheses by the x, we can add a value outside, and we can multiply a value by out front. These values, a, h, and k, will all be used to graph. Our h and our k will be used to find our vertex. Notice if this says x minus 2, 2 will be the x-coordinate of my h. But if it had said x plus 2, then my h value would need to be a negative 2. Whatever my k value is out here, if it's a plus a number, it's going to remain that same number. If it had been minus some value, let's say minus 7, then it would be comma negative 7. And then a is going to be our multiplier, and that multiplier is going to determine our slope. Just like when we graph a line, we're able to rise up and over a certain amount. This time our slope is not constant, it changes each time. So we'll take this a value and we'll multiply it, and first we'll rise up 1 times that a value and then go to the right 1. From that point then we'll rise up 3 times our a value and to the right 1. And then up 5 times our a value to the right 1, and you get the pattern. So you want to memorize 1, 3, 5, 7, 9, etc. as your multipliers that a will be multiplied by. So if we take a look at our function, our parent function or our base function, f of x is equal to x squared, let's rewrite this using this transformation language or format. So this is going to be the same as f of x is equal to x, it's just x squared, so that really means it's x minus nothing squared. And then it doesn't have any value outside, so that really means it's plus nothing. And then in front here, it must only have a multiplier of 1 because I don't see any other value. So from this, my vertex is the opposite of this value, or the value I see here because it's minus. So it's going to be 0, comma, the value that I see out here. So 0, 0. And previously, we had taken a look at finding our vertex by doing the opposite of b over 2a. And if you look at this, you do the opposite of my b. Well, b would be 0. So that'd be 0 divided by 2 times my a, which would be 2. 0 divided by 2 would give me 0. And if I plug the 0 back in, I would still get 0. So either way, getting your vertex the same. And now my slope, or how my value is going to increase by, I'll actually put that up here, is going to be 1 times each of these fractions. So it's going to be 1 over 1, then up 3 and over 1, then up 5 and over 1, and I could carry that on, but I'm going to run out of space. Okay, so we're going to take each of these and we're going to actually plot them. So I'm going to always start at my vertex. So I'm going to take this point and I'm going to move it right to the center, my vertex here being at 0, 0. From there, then, I want to use this slope. I want to go from this point, 0, 0, up 1 and to the right 1 and plot that point. From that point, then, I want to go from this last point up 3 and to the right 1. From this point, then, I want to go up 5 and to the right 1. Now, this is only half of my parabola, so I'm going to replicate or mirror the same thing on the other side. Up 1 and to the left 1. I'm going to go from there up 3 into the left 1. And I'm going to go from there up 5 into the left 1. So each of these points then, it will always have this consistent pattern. I should always get a U shape. This then represents the parent function or the graph of just x squared. Now if I want to take a look at this next example, I'm now being asked to graph the function x minus 2 squared plus 3. So if I use what I just learned, my vertex now is going to be 2 comma 3. So again, this is going to be, since it's minus 2, it's going to be a positive 2 and then a positive 3. And my slope, this time it's going to be my a value. I don't see it, so it's an a value of 1. So it's going to be 1 multiplied by each of these. So it's going to be, again, 1 over 1, 3 over 1, 5 over 1, and then 7 over 1, etc. So I'm going to take each of these and I'm going to plot them this time. Okay, I'm going to start to the right 2 and up 3. From there, I want to rise up 1. So from this point, up 1 into the right 1. From that point, I want to go up 3 into the right 1. From there, I'd go up 5 into the right 1, but I'm going to run out of space. Okay, so I'm going to go back to my vertex and up 1 into the left 1. I'm going to go from there up 3 into the left 1. Okay, and I'm going to connect each of these values then with a nice curve. And if I take a look at that curve then, I notice that I have the exact same curve. The only difference is that my graph is simply shifted to the right 2 and up 3 units. Nothing else has changed. So let's take our last example then. This time we see that our vertex is going to be negative 4, because now I have a plus 4, so negative 4, and then minus 1, so that stays the same, minus 1. Okay, and my slope this time, my slope is negative 2 times each of these. So negative 2 times 1 over 1 is negative 2 over 1. Then negative 2 times 3 over 1 is negative 6 over 1. And then negative 2 times 5 is negative 10 over 1. And I could continue, but we know we won't be counting down 10 into the right one because our limit is 10 here. So I want to plot each of these points. I'm going to start at my vertex. I'm going to start to the left 4 units and down 1. From there, then, I want to go down 2 and to the right 1. So from this vertex, down 2 and to the right 1. From there, I want to go down 6 and to the right 1. Okay, I've run out of space, so I'm going to now go back to my vertex. I'm going to go down 2, and instead to the right 1, I'm going to go to the left. And then from there, I'm going to go down 6 and to the left. Okay, and I'm going to graph this by connecting it with a U shape. Okay, and so now I see not only did my U get skinnier or more narrow, so it was stretched out because I had this multiplier in front. Okay, so I have a more narrow or a stretched out graph, but it's also been inverted because we see that this value, the multiplier, was now negative. So as opposed to my first examples, it was positive, it opened up, it was happy. Now here down below, it's negative, so it's opening down. So in summary, what I always want to do is I want to take a look at my vertex first, which will be the opposite of what's inside the parentheses, comma, what's outside. Then my slope, I want to remember 1, 3, 5, 7. Those are all over 1. And I'm going to multiply that by whatever value is out front of those parentheses. I'll connect them with a U. My domain for any quadratic is always negative infinity to infinity. But now I have to take a look at my range. So let's take a look here for my red graph. This time my range is going to start at 0, and it includes 0. So hard bracket 0, and it goes up to infinity. If I take a look at my range for my blue graph, this time the lowest y value I have here is 3. So this is going to go from 3, and it includes 3, to infinity. And then lastly, if I take a look at my green graph, or my function here, or my second example, my last one, This now is going to have a range starting here at -1 and it goes down. So that means it's going to go from -infinity to 1 and include that 1.